About 5 seconds have passed, maybe a little less than that, and 200 tons of concrete were already poured around the world. In this 10 seconds or so, 250 tons of cement were produced, equaling to the amount of around 100 pickup trucks. This is a lot of cement used to produce concrete. Now you might be wondering, what is concrete? Well, concrete is a mixture of cement, rock, sand, and water. If you take a look at the amount of water used to produce concrete, and the staggering 2.5 billion cubic yards were used in 2018 alone. Now hold on, let me put that into perspective. This is the amount falling down the Niagara Falls for 9 days straight, and it is water that you and I could be drinking. By 2050, it is expected that 3/4 of the water needed to produce concrete will likely happen in water-stressed areas, posing a dangerous cost-benefit trade-off in developing regions. So, what is the solution? Well, given the fact that 40% of the population lives within 60 miles of the coast, that is 3 billion people, why don't we take non-drinkable water such as seawater in production of concrete? Now, certain salts present in seawater may cause damage to concrete. If I take cement and I mix it with seawater, will I see any deterioration on the mechanical properties of concrete itself? In order to answer these questions, I have developed a method to synthesize the basic building blocks of concrete. Then, I have exposed them to seawater and I have tested mechanical properties using a method called nanoindentation. This method allows to measure the stiffness of these building blocks and ultimately of concrete. We can picture it in this way. If you take your finger and you poke jelly or glass, you're going to have an idea of the different properties of these materials. The same thing applies here, but at a nanoscale. We can idealize a nanometer in this way. A nanometer is to an orange what an orange is to planet Earth. So it is indeed very small. At this scale, we can simulate the life service of a concrete structure exposed to seawater for 100 years or more in just a couple of weeks, saving a lot of testing. Our results show that no reduction in the stiffness is expected when using seawater. In fact, an enhancement is detected. So this is very promising. In these 180 seconds that I've been talking to you, 300,000 families in Africa could have saved the amount of 2 days of drinking water if we use seawater as a replacement for concrete production. Thank you.